Hi everyone, good morning and welcome to AeroCampus 2022 organized by Singapore Airshow. Thank you for taking time to attend this AeroCampus event live. I'm Cameron from Science Centre Singapore and I will be taking you through the first segment on the virtual STEM workshop this morning. We will be showing you a series of pre-recorded videos to introduce some of the school-based STEM-related aviation activities. These are taken from 4 local secondary schools that focus on the future of transportation in their STEM applied learning programs. Before we start, just a reminder that you may post any questions you may have in the chat box too. May I request for a thumbs up or an emoticon to just check in with how are you feeling today. Feel free to use the emoticons at any point of time so that we feel your presence too. First up, we have a showcase from Ping Yi Secondary School who will be showing you their school's activity called the DIY Chopsticks Glider. This is something that anyone can give it a try using materials easily found from home. They will also introduce some aeronautical concepts and some of the tips and tricks to calibrate the glider to fly with flying colors. Let's take a look.
Ping Yi Secondary School is the only school in Singapore that offers a unique blend of both design and aeronautical engineering in our applied learning program. We offer students an opportunity to understand aeronautical science. We use a hands-on approach, enabling students to understand concepts through conducting experiments. It is all about students discovering the joy of learning through experiencing the world of aeronautics as a designer, inventor, engineer, and even a pilot.
For our design course, our teachers encourage us to come up with our own solutions for our projects. These projects aim to improve the lives of people in our community. It was really fun to tackle problems in our own way. And there are also many different tools and technology in our school for us to explore and learn.
The makerspace is where we turn dreams into reality. We have laser cutters, 3D printers, and all the equipment we need to create our own designs.
Some of us designed our products on the computer-aided design and created them using the 3D printers. It was such an exciting experience.
Using the wind tunnel, we can see how the shape of our designs affect the airflow and how well it works with our gliders.
This helps me to understand the theory of flight in real life.
We build actual flying machines too, such as gliders and even drones that can be programmed to follow our commands. Isn't it exciting?
We built this drone, and now the best part is flying it.
I found that there's so much more to design and that I definitely want to be a designer in the future.
I want to build my own planes when I grow up.
I want to be an astronaut, an inventor, or an engineer.
In Ping Yi, our dreams can take flight.
Hello everyone, my name is Wesley.
And my name is Lois.
And we are students from Ping Yi Secondary School.
Today we will be bringing you through the process of building a chopstick glider using materials you can find at home.
The chopstick glider, as the name implies, has its main body made out of disposable chopsticks. The wings and tail are made from thin foam which you can either buy from bookstores or you can recycle the cardboard from pizza boxes. To start, you'll need the following materials: a printout of our Chopstick Glider template, a piece of foam sheet around A4 size or thin corrugated cardboard, a disposable chopstick, one rubber band, and one small piece of blue tack. 2 squares will do.
For tools, you will need the following: a pen knife, a ruler, a hot glue gun. This is optional. If not, you can use craft glue instead.
Before we start, let us familiarize ourselves with the pen knife and the hot glue. For this activity, we will use around 3 segments length of the blade, 1, 2, and 3. Any longer and the pen knife will be wobbly and unstable, while a blade that is too short will be difficult to cut with. Always remember to lock the blade into position so that it doesn't come loose during cutting. When holding the pen knife, remember to grip it firmly and make sure that it has as much contact with your entire hand as possible.
As for the glue gun, always keep in mind that the tip is very hot, and always remember to place the hot end pointing away from you. If you don't have access to the hot glue gun at home, you can always replace it regular white craft glue. Just remember that it takes much longer for the glue to dry.
The template for the Chopstick Glider is available for download online. You can either draw your own designs on the template or superimpose the template designs over images that you like or have downloaded from the internet.
Glue the template over the foam sheet or cardboard and wait for it to dry. And once everything is ready, you can start to cut out the parts.
When you are cutting the template, remember to hold the pen knife at a low angle for a smoother cut and go over the lines a few times in order to cut through the foam, rather than 1 or 2 deep cuts. This is especially important if you are using cardboard, as it is hard to cut through the material, and using too much force can be dangerous if you slip and accidentally cut yourself. When cutting, keep the angle low so that the pen knife slices through the foam or cardboard at a very low angle. This maximizes the cutting contact surface and makes it easier in the cutting process. In addition, cutting at a low angle has the added safety bonus of acting as an early warning of sorts. If you have a thumb or finger in the way, the edge of the penknife or your hand will knock against your finger and give you some time to move out of the way. It is important to ensure that the edges of the foam glider parts are cut cleanly. If you made any mistakes and ended up with jagged edges, don't worry. Just place your ruler over the edge and cut again. It'll take some time, but be patient and you'll get it done.
Once all parts have been cut out, we can start to prepare the chopstick as the main fuselage of the glider. Cut or break off 5 to 6 cm of the shorter end and trim off any loose stray pieces of wood.
Before you glue the tail part to the chopsticks, look for the thin lines indicated on the rudder and the elevator. Using a ruler, press down on the lines to create a crease and bend it a few times. This will make it easier for you to adjust the glider for flight later.
Glue the tail parts to the end of the chopstick. The rudder should be glued to the top end of the chopstick, while the elevator should be glued to the bottom of the chopstick. Make sure that the elevator flap portion of the tail is free to move up or down so that you can adjust it later for flying. While gluing, make sure all parts of the tail are aligned correctly. It should look like a T if you put upside down. And with that, you have completed your tail section.
And now we'll be moving on to the wing section. I want you to look out for two thin lines that you have cut out. Bend? You forgot! Just like with the flaps for tail section, I want you to press down on the lines and slowly bend the wings upwards. Be careful, the foam can break. Bend slowly until both wings are tilted up at the same angle. What you just did was creating a dihedral for your glider's wings. This makes your glider more stable when you launch it.
To attach the wing, we will need to tie the rubber band to the chopstick. Get it? I'll do it one more time. And that's it, you completed your glider.
And now for the final touch to your glider. This is really important now, so I want you to listen really carefully. Take about 1 square's worth of blue tack. Now, this is very important. I want you to listen very carefully. Take the blue tack and place it in front of the chopstick. And that's it. Your glider is done.
Why won't it fly properly?
Your glider may or may not be able to fly properly after construction. So this is why I'm here, to help you into making your glider the best there is. Alright, now let's give it a go and see how your glider flies. If you notice that your glider flies upwards quickly, loses power and then dives back to the ground, it is probably unbalanced or has too much lift at the front of the glider.
There are 3 things you can do. Firstly, check that the elevator flap is straight and not bent upwards. Secondly, you can shift the wing slightly backward, just roll the rubber band loops backwards. You can make a small mark so that you can remember the position. And thirdly, this should be the last option. You can add a little bit of blue tack to the nose of the glider.
Launch your glider again and observe its flight pattern. If it goes nose down directly, it may be too heavy or unbalanced. There are 3 things you can do. Check that the elevator is straight and not bent downwards. You can bend it slightly upwards. Number 2, shift the wing slightly forward. As usual, use a pencil to mark out the position of the wings in case it shifts after multiple launches. Lastly, take out a bit of blue tack from the nose of the glider. Your glider might fly towards the left or right during its flight. This is normal, and you can adjust it using the rudder at the tail of the plane. If your glider flies towards the right, you can counteract this by bending the rudder to the left. If your glider flies towards the left, you can counteract the direction by bending the rudder in the opposite side to the right.
Now that you're done, go find a good spot and launch your chopstick glider. Yeah!
Wow, this is a really well-built glider. Wait, smell of chopstick?
Nice ride! I made it in class just now.
Yes, how do you manage to make it fly so well?
Magic, I guess.
Looks like you don't really know how planes and gliders can fly in the air. Since you have some time, why don't we learn about the forces of flight?
Sure!
Okay, let's go to the aviation room and then see the wind tunnel.
Wow, this is the wind tunnel? I've never seen it before.
Yeah, it makes it really easy to understand how a plane can fly in the air if we put a model inside. Let's put this model inside and see how it goes. Alright, you ready?
Let's go, man.
All planes fly because of four forces. The four forces are lift, thrust, drag, and weight. When your glider flies through the air, lift from the wings holds it up. The thrust from the glider comes from your arm when you launch it. Drag from the air and the shape of a glider's body makes it slow down. Its weight brings the glider back to Earth again. The way the four forces act on an airplane makes the plane do different things. Each force has an opposite force that works against it. Lift works opposite of weight. Thrust works opposite of drag. When the forces are balanced, a plane flies in a level direction. So this is how the four forces of a plane act to help a plane fly and stay in the air. Do you understand?
Yes, I definitely understand, yes.
Great! Thank you for spending your time with us and have a nice day. Bye!
That was really interesting. It makes me want to try and reuse the chopsticks and cardboard lying at home to make a glider. Audience, please try it at home too. Not to worry, if you missed out some of the information, we will share all the resources and information from these workshops at the end of the fourth video. Stay tuned. Next, we have Coding Drones with Chankateers by Changkat Changi Secondary School. In this video, you will be introduced to the learnings that can take place at Changkat Changi, as well as the wide-ranging applications of drones in our world today. It is amazing that all Chankateers will learn about drone programming during their applied learning lessons in secondary 2. From the video, you will get a chance to learn the basics of coding in drone programming and watch Chankateers explore different codes to allow the drone to overcome obstacles.
A school is a special place. A place to try new things, where the imagination can take flight, and the world becomes the classroom. A place to grow, where we learn from our teachers. learn from our friends, to create our own magical experiences, a place to stand up and rise up to challenges, to achieve our dreams, whatever they may be. My school is Changkat Changi Secondary School. It's a special place I call home.
Hi everyone, my name is Mr. Ang, and today we will be doing drone programming. Okay, so what we will need today will be the Tello Edu drone. We will need your iPad, and in the iPad you will need to look for the logo with the app with the bird sign. That is your Swift playgrounds. We are going to introduce to you the app that we are using to do the programming. So if you have your iPad with you, you can go to find the app that's called Swift Playgrounds. The logo looks like an orange dove here. So once you're inside, there are different modules. We're going to look at the one that says Tello Space Travel. So once you click it, it will show you an introduction, short clip on what it's about. So I'm going to just skip that for now. But basically, the context is that you're going to operate a drone from outer space and you have a spaceship. So now we are going to start on to talk about taking off and landing. Okay, the first lesson you will learn is about taking off and landing. So this is a tutorial, so you can see that here are the instructions for the tutorial. They'll tell you what to do, and they'll even tell you what the commands to type in. So this part here is where you key in your commands, your code, so that you tell the drone what to do. This part here just shows you that whether the drone is connected, and it gives you a bit of a visual, as well as this is where you run your code. So I'm going to show you how to type in the code. In this tutorial, all the code has been keyed in for you, but it is good that you learn how to key in yourself. So if you click here, you can see that there's a keyboard here. Actually, you can bring up. You press this up arrow, okay, and I'm going to remove all my code. Okay, I'm going to start from here. So usually you can just type in, let's say take off, and I'm going to put open and close bracket. So that is my first command. I click tap the enter button or return button. You can key in another code. So that's one way you can actually type it in. Another way you can do it is to actually choose from the options above. So sometimes you type in a few letters, it gives you a predictive command that you can actually key in. So in this case, I'm going to click this one because I want this one. This UINT is actually an integer that you can key in. So I'm going to just click here. And let's see, I think I have to key in my number. So I'm just going to key in 2 seconds. I want it to hover for 2 seconds instead. So go to the next line. I can now choose to land. So I can click from here, or I can type it out. Okay, so when I'm done, I can show you again. So these are the 3 commands, and I've just typed it out by myself. So once you're done, you can actually connect your drone, and you can click run my code to fly it. Okay, this next section, we're going to learn how to get the drone to fly forward and backwards. So the first command, always remember you must take off. Then after that, you need to, I want to fly forward, so I'm going to tap this one, and I'm going to put there my number, 100 cm, which is 1 meters. Sometimes if you cannot find the predictive word that you want, the code that you want, you can just type in the first few letters, and then you'll still see it. So now I want to fly backwards. I want to type 100. Okay, and then finally you will click land. So this is how you do the code for forward and backwards. You're going to learn about how to make the drone fly up and fly down. The new command you will learn here is actually fly up and fly down, which you'll see later. how to know how do you control how high it flies up is given in cm here, so you actually can fly up to 1 meter or down 1 meter. So I like using the predictive words because it helps me to really decide what I want, so it's much faster type that way. So I want to take off, I want to fly up, and I'm going to put my number 100 because that's how high I want to fly it up at, and then I want to fly down, okay, and another 100, okay, and then after that I will just need to click. Okay, you realize that the bracket cannot go down, so I make sure I click in the right place, go to the next line and click land. So this is my code for ascent and descent, to fly up and to fly down. This next section will teach you how to fly the drone left and right. So previously we already learned how to fly the drone up. So it's a fly up command, fly down, fly forward, and fly backwards. So now the command is still similar. Instead of the previous commands, you have fly left and then fly right. The first command to take off, just remember you need to take off the drone, if not the drone can't execute any other commands. We're going to fly left first, so I'm going to click fly left, and this time around I'm going to try to type it out. So you see fly left, and as I try to type, I realize that there is a red dot that comes on the left side. So this red dot simply means that the command there's an error or it's not complete yet. So whenever you see a red dot, do not panic. It just means that your code has some errors here. You will want to edit it. So I'm going to type out the whole command instead of just choosing the predictive one. Bracket. I need to type in cm, type in a colon, and then putting in my number. So I'm going to fly 100 cm to the left. Okay, so I click an enter sign. Sometimes when you type it by yourself, there's a chance of it getting wrong. But you see here, there's no red dot, means that I typed correctly. Everything is fine. Okay, the next one I'm going to just use this and I'm going to key in my number that I want, and I need to land. Okay, so this is my command simply to get a drone to fly left and right. Let's run my code to see if that works. This next section, we're going to learn how to get a drone to actually rotate left and rotate right, or we call it turn left and turn right. So now let's learn how to type the code. I'm going to delete all the code again so that you can learn to type it yourself. Take off. Okay, that's the first one. After that, I want it to make sure I can turn left 90 degrees and then turn right 90 degrees. So you see in this code, right, it's slightly different. Instead of giving you a unit in cm, it gives you a unit in degree. And this you have to use your what you have learned in geometry in degrees to actually learn how to navigate. So 90 degrees is simply a right angle to the left. 180 will mean turning all the way behind. Okay. So now after I turn left 90 degrees, I want it to turn right 90 degrees again. I'm going to choose this one and type 90. So that way I'll be facing the same direction as I started. So after all of this, I just click land, and that will be my code that I need. Okay, so let's run my code to see how this works. Okay, in the previous videos, we have really learned how to get a drone to fly up, down, forward, backward, left, and right. So in this section, we're actually going to learn how all this actually can serve a function, serve a purpose. So you can see here, the challenge here is to actually get this Tello drone to fly around this space station. The path has been marked out for you. So you need to realize, okay, I need to get a drone to fly this way, to the right, forward, and to the left, backwards, and back to my landing pad. So first command, I need to take off, And then looking at where the drone is actually in the middle behind of the space shuttle, the space station. I need it to fly to the right first. So what I'm going to do, I'm going to key in a fly right command. And then in this case here, the number given to me is only 90 cm. I don't need it to fly 180 yet. So I need to fly 90 cm. So after this, let's go back to the diagram. I need to get it to fly forward. So fly forward for 180 cm. So fly forward 180 cm. The next command, let's look at it. So after it reaches here, I need to fly left. If you can try to visualize from the drone's perspective. Fly left 180. So let's click it. Fly left 180. So as you can see, right, if you don't type in anything, there's a lot of predictive words that can come and suggestion words. So you need to type in a few words, at least a few letters, so that they know what you look. It's easier to narrow down what you're finding. Okay. So now fly left here. I want it to fly backwards. So let's type fly. Okay, I want it to fly backwards, and this time around it's also 180. So if I go back to trace my code, it's right, forward, left, backwards. Now I want it to fly right again, but it's not 180. I want it to fly back to the landing pad, so that's only 90. So let's try fly right and 90. And if you look at it, we are done, but we're actually missing one important code, and that is to land. We need to make sure that the drone lands at the end of our code. Great job! You have just learned the first few commands for drone programming. Do you know that actually there's another function called drone swarming? So this is when you use one device to actually code and actually execute for many drones flying at the same time. So that's called drone swarming, and you'll see an application of that during the National Day Parade in 2018. So I hope that you continue to enjoy learning coding and programming the drone.
Hello everyone, my name is Clark.
I am Hansini.
Hi, I'm Anushree.
And I'm Clive. We are from Changkat Changi Secondary School. Today, we are going to share with you what we have learned in our school's Applied Learning Program. Let's begin! Hey Anushree, what are drones?
Drones are unpiloted aircrafts. They are able to carry out an impressive range of tasks, ranging from military operations to package delivery. Drone sizes can range from being as large as an aircraft to as small as your palm. In recent times, drones are deployed in urgent situations to help save lives. For instance, when an earthquake strikes, drones are often used to assist in rescue efforts. Whenever first responders have difficulty in maneuvering through impassable roads and damaged infrastructure, drones come in useful in effectively locating people trapped in collapsed buildings.
Wow, I did not know that drones can be so useful in our lives. In Changkat Changi Secondary School, students are exposed to various lessons conducted through our ARP programs. Students learn how to code drones and use them in different situations. Our students use the app TeloEdu while learning how to code. The app and educational software allow students to hone their observational skills, acquire a sense of spatial awareness, and boost their creativity.
The app includes various functions for different coding systems, which allows students to use their creativity to plan their own experiments. Some functions include motion, control, light, and sensors. As the drones are wirelessly connectable, this makes the drone portable to use. Now, we're going to try and do a double backflip, but before that, let's show you how to connect the drones. Firstly, go to the home page and click on the blocks page. Secondly, click on the motion feature and insert takeoff and up 50 centimeters. Lastly, click on the control feature and insert your desired magnitude and prepare your code for your drones to do a double backflip.
As seen here, the drone is being connected through Wi-Fi. A purple light will be illuminated to show that it is connected.
Wow! It must be really fun for the students in Changkat Changi to take part in such programs. The app includes numerous functions. In order to use these functions, there are boxes for students to input their estimation of their desired movements of the drone. Furthermore, students can apply their knowledge learned during their maths lessons, such as topics on graphs and quadratic functions, into the function. This also allows them to apply the knowledge that they have learned across disciplines.
The fundamental knowledge of aviation also comes in handy while using the coding system. This allows students to have a better understanding on how an object interacts with particles in mid-air. A basic coding system requires planning. Firstly, students will need to determine the destination and plan their route. Subsequently, they will input the motion function into the coding system and determine its direction. Students can also execute simple stunts such as a backflip using the Tello Edu app.
Wait, the drones actually can do a backflip?
Yes! One very important fundamental of coding is understanding of the Cartesian coordinate system. In order to fly the drone in various shapes, mathematical formula come in handy. The formula is as follows. Angle required equals to 360 divided by the number of sides. For example, if a student wishes to fly the drone in the shape of a square, they are to use the formula and divide it by 4. Hence, using 360 divided by 4. The drone will then fly in 4 sides, completing the shape of a square.
Wow! Didn't know about coding drones at first, but after hearing how it is being coded, it must be really interesting and fun doing it. I am so excited to learn more about flying a drone.
So Hasini, what will be our objective today?
Our aim is to use drones to conduct rescue efforts. For example, packages can be sent to victims of natural disasters. Drones are designed to fly through obstacles and provide those in need of help. In such situations, the victims are able to obtain appropriate attention quickly and use drones to send aids to the affected victims. In real situations, we could use bigger drones to transport appropriate help to the victims.
So, for this project, we will be using drones to fly to a higher altitude. But first, we must find possible ways for our drones to fly to the second floor. So here are the 3 methods. The first method is very simple. We'll be using motion bars only. So the drone will take off to an altitude of 500 centimeters and proceed to move forward. Then the second method is when the drone will go around the obstacle in the base area. The drone will move 100 centimeters to the right to dodge the obstacle. Then the drone will move forward again to land. Or another method is by going above the obstacle by elevating to 100 centimeter altitude, then move forward and then land again. There are many other situations which we can use the drones for. You can try using other creative methods as well. There are many other situations which we can use the drones for. You can try using other creative methods as well.
Yes, that's true. Now, I would like to find out more about the drones as well. Well, during this project, I've learned that the drones are controlled by the Tello Edu app that we are using to program the drone. It's not complicated to use the app and makes coding simple for users.
Well, agreed. I have met people who are not capable of real coding on computers, games, so far and so on. Well, this project can be developed and allow the public to be well aware and provide aid.
But what if they do not use the drones properly?
Yes, about that. It is very important to use drones with safety measures. When it comes to handling it, do not hold the drones too close to the propeller. That is very, very dangerous. It may result in injuries when the drone is accidentally turned on. Do not fly drones too near to yourself, people, or obstacles to prevent injury to others. When you want to turn on the drone, do not hold the power button for too long or the drone will reset and data will be all lost. And lastly, always remember to charge for at least 10 to 20 minutes to avoid overheating the battery.
Wow! Now we all know how to use them properly, so using it will be more safe.
Yep. Well, that's all for today. Thank you for watching our video, and we really appreciate your efforts in learning this. Bye-bye.
SOAR. It stands for Student-Centered Opportunities in Aerospace Industry. It is our unique aviation program for all Chankateers. When you join us in Secondary 1 and 2, you'll be introduced to the basic principles of flight, build your own glider, learn about basic programming, and fly your own drone. All these 1-hourly aviation lessons are built into our weekly curriculum for all students. Moving forward to next year, we are excited to include the flight simulator lessons to provide a more authentic flying experience for our students. These opportunities will allow our students to learn beyond the science curriculum and appreciate how their learning can be applied to real-world problems.
A key strength of our aviation program is the best industrial exposure we are able to provide at the secondary school level. We are truly grateful to our partners who are from renowned learning institutes and established companies in the aviation industry. Students will get to learn and interact with lecturers and students from Singapore Polytechnic and staff from Rolls-Royce. Through these partnerships, our students gain exclusive visits to NASA in Houston, USA, the Airbus assembly plants in Toulouse, France, and the Hong Kong International Airport. They also had exclusive visits to SIA Engineering Company and Rolls-Royce to have their first-hand exposure to the aviation industries.
We provide a platform for students to apply what they have learned through various competitions. These competitions allow them to display their creativity and, more importantly, train them to search deeper for answers on their own and with their friends. While our students have won numerous awards over the years, the learning process is what each teacher here values most. It brings me great joy to see them mature into independent learners.
We hope to see you join us next year. Soar with us here at Changi Secondary School. We are your first step into the world of aviation.
Wow, I like how the drone did a backflip in the video and it was so eye-opening. Chankateers sure make it look so easy to do the coding, and I hope you get a chance to try it out in the future and code the drone to deliver something nice to someone to make someone's day. Let's go for a short 2-minute advertisement break for you to take a look at some of the exciting and upcoming events at Science Centre.
Experience Brickman Wonders of the World. An epic journey through history's greatest masterpieces, brought to life in Lego bricks. From the Great Wall of China and Taj Mahal to the heights of the Empire State Building, with more than 50 incredible displays to explore. This world-class exhibition is a hands-on trip through history. Don't miss Brickman Wonders of the World.
Welcome back. We are moving on to the third video, which will be showcasing the flight planning and simulation by Northbrooks Secondary School. The flight simulation is part of the school's aerospace program for all lower secondary students to learn basic flight and STEM concepts from geometry to physics in order to pilot an aircraft. In the video, you will see how the program provides an avenue for hands-on practical learning. Also, you will get to meet and learn from passionate students who have experience in the flight procedures, checklists, emergencies, and even planning for pre-flight flying routes to the required destinations in the flight simulator. I hope that you will enjoy this video and consider joining the aviation industry after this.
Hello everyone, my name is Ascendus, a secondary 4 student in Northbrooks Secondary School and also the flight simulation instructor for Youth Flying Club. Today I'll be talking more about our school's applied learning program, of which targets and focuses on aerospace and aviation related aspects. Now, what you're seeing here is a multi-panel display of a flight simulator. There are many different types of flight simulators. However, the most commonly used one that trains and develops different pilots of different fields would be this multi-panel display. It really is a simulation of the actual cockpit we can see in different types of different varieties of planes in the industry currently. For example, the A320s, Boeing 737, Cessnas, and every different type of planes that we could really fly. Now, what you're seeing here is an example of our Cessna flight instruments. So, over here you can see is our airspeed indicator. As the name says, it is a display that shows the pilot on what speed the plane is currently flying at. Usually, we will take off at 80 knots and we will pull back at 120 for landing. And during approach, we will display back towards 100 knots. What you're seeing here is the altimeter. It will display how high a plane is flying. For example, a commercial aircraft will fly up to 35,000 feet, and our normal circuits could go as low as 1,000 feet in fact. So it's really a variety. Over here is the turn coordinator. It shows how deep you turn and the quality of which you turn a plane or an aircraft. And this is the vertical speed indicator. It shows how high you will take up or pitch up in aviation terms, and how low you pitch down, in other words. Now, over here is the example of our Cessna Skyhawk ST model cockpit. So, over here you can see our display of our aircraft's call sign, of which is November 176 Charlie Mike. And over here is just an example of what's the frequencies and different turn coordinators, different display indicators, and our main panel, for example, the lights, strobe lights, landing lights, and our different aspects that a pilot may require in order for him or her to operate an aircraft. Now, this is the joystick we use in Northbrooks Secondary School. It is the most fundamental and most basic joystick an amateur pilot can start off with. It is rather easy to use. So you can see here, this is the joystick itself. You can rotate and control the aircraft by pulling back during takeoff, or when you're taxiing on the runway, or taxiing back towards your gate after landing. Over here are still buttons. For example, you can set a certain button towards a certain control, such as flaps, slats, or even your landing gears. Over here is your throttle. What the throttle does mainly is for you to accelerate and decelerate an aircraft. So for example, when we are taking off, we would first pull the throttle before we rotate the joystick itself. Now, let's start off by explaining Microsoft Flight Simulator. So, this is the most commonly used training aspect in Youth Flying Club in Northbrooks. So there are actually different types of tutorials and missions that is set in Microsoft Flight Simulator X. What we get our secondary students to start off in Flight Club will be to learning how to take off. The most fundamental aspect of a pilot is the requirement of knowing how to take off before he or she is able to perform other maneuvers such as landing or towards autopilot, how to operate a certain gear whatsoever. So this is the utmost beginner skill level that we expect all our cadets to first manage to handle, and that will be takeoff. Following that would be the example of a tutorial. For example, the green box here that you can see is actually a pathway or a way marker, we say, that we aim our pilots to be able to enter. So if you are able to fly through the certain waypoint, it means that you are able to achieve a certain aspect that is towards a professional level. So for example, a basic level of flight would ensure that from the runway itself, you have to accelerate at a certain angle and pass through these waypoints. Now, this is another and a new flight simulator that we have recently started using in Northbrooks Youth Flying Club, and that will be X-Plane 11, another software that is similarly towards Microsoft Flight Simulator. However, as our school mainly uses the Cessna Skyhawk plane, we have recently moved on to a new system called the G1000 flight system, which controls a more advanced flight simulation system with advanced panels and displays. Hi everyone, I'm Ascendus. Now I'll be presenting to you guys on how we operate this FSX simulator on the Seletar circuit in our Northbrooks Applied Learning Program, which is targeting on aviation. Please follow me. So now what I'm doing is calibrating the joystick and will be accelerating forward on runway 03, which is located on Seletar Airport. All pilots are required to start off their taxiway on the center line, and same thing goes for landing as well. Now I'll be accelerating to the speed of 80 knots before I rotate up for takeoff. Right now we'll be rotating. Just slightly pitch up and the plane will accelerate off. Now we're airborne and I will be accelerating to the height of 500 feet before I rotate towards the left. Alright, now we are aligned and perpendicular towards the Sembawang area, and we will now be pitching towards the left. Just a slight caliber will do and the plane will turn towards the left side. What you can see in front is the Malaysia land, and our pilots tend to not fly over that land. We tend to fly over just the reservoir area. Now it is important to ensure that your speed is below the green bar, as that would indicate that you are not overspeeding. Overspeeding could be a hazard, as you may not be able to control your speed in dire needs. Now, our pilots in ALP and in our school are taught that when they see the Sembawang land in front, that is an indicator without GPS for them that they are perpendicular towards the airport itself as well. Now, I'll be accelerating towards the height of 700 feet before I rotate once again. Now, as you can see on the altimeter, I'm currently on 700 feet. And I will now be rotating for my final approach towards Seletar overhead. Our pilots are recommended to ensure that they are in between the speed of 100 to 120 knots in order for the best and utmost performance of the Cessna Skyhawk aircraft, as that is the most appropriate speed that is recommended for them to approach it. Now what you can see below is the Yishun area as we are flying across and overhead. I am now perpendicular towards runway 03, which is the runway that I will be approaching in on. As you can see, I am now perpendicular to the runway, which is Whiskey Sierra Sierra Lima, also standing for the ICAO call for Seletar Airport. Now, our pilots are recommended to ensure that they fly over the Seletar Reservoir, the Seletar Lower Reservoir in fact, before they are able to make a final approach. Our ALP cadets and students in Northbrooks are taught towards making a long approach, as a long approach would ensure that the aircraft has enough velocity and speed for them to come down for the final approach. Now I am currently overhead for Seletar Airport. This is Seletar Airport, as you can see over here. I will now start to decrease my speed as I come in for the final approach before I make the approach turn. Now the reservoir in front is actually Pierce Reservoir. That is the sign that we are good to turn before we make the final approach. For final approach, it is recommended to be below 1,000 feet so we can make a corresponding turn and approach onto the runway and not bounce. Now I'll be slowly decreasing my altitude, as you can see. Just slightly below 180 knots as I come in for the final approach. Now I'll be making the final approach turn as I come in for Seletar Airport on my left-hand corner. Not to turn too much, just a little bit and the aircraft will be good to go. As you can see, Seletar Airport is on my dial left. I'll be now coming in for WSSL. Just a little bit of turbulence. Now, as you can see, Seletar Airport is in front. The 4 red light indicators or white light indicators would show whether your altitude is just fine. It is an indicator of which pilots used in order to gauge their altitude on whether they are suitable or competent enough to land. Now I'll be decreasing my altitude towards below 500 feet momentarily for my final approach. As you can see, my speed is currently going beyond or below, in fact, below 100 knots as I come in for the final approach. 2 white lights and 2 red lights will be the best sign that you're of the right altitude as you come in for your final approach. What I'm doing here is called a long approach. It gives pilots the suitable amount of time to decrease their speed and their altitude before landing. Now 2 white lights and 2 red lights. I will now be decreasing my altitude, speed below 80. Once I align for the center line. Right, good to go. I will be slowly pulling back for my ground wheel to come in contact first. Slight bounce, that's fine. And decrease speed slowly, brakes on. As I come in for a complete stop at the end of the runway.
Hey there, my name is Nabil and I'm from Northbrooks Youth Flying Club. And today I'll be sharing about how we plan our flights on our flight simulator before flying. So now I'll be talking about how we plan our flights. So firstly, we find suitable waypoints. So waypoints are basically computer track coordinates for us pilots to fly through in the airspace. So this is also to prevent any collision in the air or probably flying into any restricted airspace. So secondly, we find distance between waypoints. So the distance is also helping us pilots to calculate how much fuel we need to fly to the airport. So thirdly, we find headings between waypoints. So heading is basically to also prevent any collisions in air, especially also to route us to the correct line. So lastly, we find you also have to find the cruise altitude, as we might actually not being able to land at the correct timing or a correct height. So this is a flight log that we have planned. So basically, we will be taking off from WSSL Seletar, which is also an airport code that has been defined by the International Civil Aviation Organization, and also another airport code, WMKM, which is Malacca, which is also known as our arrival airport. So, these are the waypoints. So Alpha and Beta are also an additional pre-defined waypoints that has been also pointed out and chosen by the ICAO. So, yeah, we'll be taking off from WSSL up towards our second waypoint Alpha, and from here to our third waypoint Beta will be 81 nautical miles with 299 readings all the way up, and also to add on to from Beta to WMKM Malacca will be an additional 24 nautical miles, and the pilot will be flying at 284 degrees. Now, this is a sample navigation log that we have planned, and which has been generated by our flight planning software, SkyVector. So basically, SkyVector is just a planning software that most of the pilots use to actually plan their flights. So this is the waypoints that we have chosen. These are the information between each waypoint. So we have the heading here and the distance here.
Greetings, my name is Daniel Hanif and I'm from Northbrooks Youth Flying Club. Today, we'll be flying to Malacca Airport from Singapore Seletar on a Muni Bravo. We'll be cruising at flight level 3000 feet at a speed of 100 knots. After departure, we will make a left-hand turn to waypoint Alpha, followed by waypoint Gupta, finally approaching WMKM Malacca. I have entered the flight plan into the G1000 flight management system. We will be departing now. We will now begin our takeoff route. I have set my desired takeoff trim, set flaps 10 degrees, set landing lights on, mixture rich, and throttle idle and at 2000 RPM. Knots. Thank you. I'm now positioning the aircraft to approach Malacca Airport.
Now, I'll be talking more about Northbrooks' applied learning program, of which targets aerospace, and it really cultivates our secondary school students in the interest for aviation. Now, firstly, Northbrooks' applied learning program of aerospace not just targets on flight simulation, however, we have very different aspects of which is very relevant towards aviation industry. For example, glider making, and there's even theory of flights that is very relevant towards aviation. Now, how does that cultivate the interest in aviation for our secondary school students? Well, because it is actually a part of our timetable and a part of our scheme towards developing their interest in aviation. Through this process itself, many secondary school students are able to interact with such technology that could be a rare opportunity of which not many students in Singapore are able to interact with. Through this process, they really get a once-in-a-lifetime opportunity, if otherwise, to really be engulfed in the field of flight simulation. Thereby, many students that come out of our flight learning program actually do want to be part of the aviation industry in the future. And there is a common misunderstanding that aviation industry refers just to pilots. Well, that is incorrect. Many of our students has expressed their interest in being part of the aviation industry in general. For example, being an air traffic control, being a customer service manager in our airports, or even a flight engineer. So through all these aspects, we can really see that through these programs, it aspires and really sparks the interest of our students. In upper secondary, Northbrooks has really given me a chance or an opportunity to explore more into the aviation industry. For example, many students in secondary 3 that are selected has an opportunity towards going to different polytechnics in Singapore for an advanced elective module. For myself personally, I have participated in the Nanyang Poly Aerospace Management Program that has been conducted last year in 2021. Through that program itself, it has really developed my interest towards more of being a pilot, and from there, I wish to pursue a higher tertiary education in the future in Singapore, for example, taking up a degree or even a master's in aerospace related courses. Specifically, in my interest, I believe that I wish and will want to become a military or commercial pilot, and through this program in Northbrooks, it has really given me the opportunity, and if given a chance again, I will always participate in this course that's been given to me.
This is inspiring to see how the students make it look so easy to fly a plane. Maybe I should give the flight simulator a try. In this fourth video, we will feature the future of personal air vehicle by Compassvale Secondary School. Compassvale Secondary School's Aeronautics Applied Learning Program offers students a myriad of opportunities to develop their interests and talents in the building and flying of various flying machines. In the first part, you will hear about the students' reflections from their lessons in designing and creating their very own personal aerial vehicles as they imagine the future of air transportation. In the second part, members of the Aeronautics Club co-curricular activity will showcase what they have learned and achieved through the sessions and how this has fueled their passion to continue pursuing aviation.
Good morning, and thank you for joining us in this segment of the AeroCampus 2022. We at Compassvale Secondary offer our applied learning program in the field of aeronautics. Through our ALP, we provide a myriad of opportunities to develop students' varied talents and interests in this field. In our Tier 1 programs, we seek to build a strong foundation of aeronautical knowledge through weekly STEM in aeronautics lessons and in the infusion of aeronautics in relevant instructional programs. Through our Tier 2 programs, we nurture our students' interests and aptitudes through exposing them to various workshops, enrichment opportunities, and learning journeys. And finally, in our Tier 3 programs, we develop a strong pool of aeronautical talent through our Aeronautics Club and other related CCA activities. First, in our Tier 1, all students go through comprehensive aeronautics modules in Set 1 and 2 and earn for themselves the Singapore Polytechnic Young Engineers Award upon completion of both modules. Students also relate what they learn in physics, math, and design and technology to real-world applications in aeronautics. Through our aeronautics co-curricular program, Students also have the opportunity to attend various aeronautics enrichment workshops, such as the building of unpowered gliders and drone flying, and participate in elective and advanced elective modules in the polytechnics and ITE, and go on local or overseas learning journeys to Japan. Talented students may also join the Aeronautics Club as a CCA and take part in various aeronautics competitions. Our students have consistently won many awards in the annual Singapore Amazing Flying Machine competitions organized by the Defence Science Organisation and Science Centre. Next up, we will hear more from our students as they share about their designs of personal aerial vehicles from the STEM in aeronautics lessons. Secondly, our CCA members will also share about the various interesting flying machines they have built through their CCA sessions and how the ALP experiences have fueled their passion for aeronautics.
Hello everyone, I am Nazura and today I will be sharing with you my group's PAV. So our PAV is a pair of shoes which has wings, and the middle two wings are designed such that it could be able to connect with each other to form like a hoverboard. Inside the shoe there is two sort of levers that will allow the person wearing it to move left or right. And at the sole of the shoe, there is an engine to power the shoe. So this shoe is supposed to enable students to get to school faster so that they could wake up later. And some other features of this shoe is that it is compact, it can become like a hoverboard, and it can also be flown easily with practice. It has an engine that could last long enough. The only limitations is that it can only fly for 30 minutes, which could be a problem for students who live further than 30 minutes from their school.
Okay, hello everyone. Today I will be sharing about my group's PAV project where we have discussed to make a jetpack. Actually, we thought a jetpack would be really useful as that it can travel to destinations much faster than other transports like cars or planes because there will always be traffic jams. So another reason is that it frees up roads for pedestrians too, and there will also be more space for land purposes to be built on. So moving on to our jetpack, we have the controller, which is the main thing that controls the jetpack. We also have seat belts for extra protection in case we have many seat belts for extra protection in case the person just falls off the jetpack. And propeller, we chose at first our main idea was rockets, but we thought they will burn the person, so propellers would be more suitable. But while it comes with many benefits, I guess it comes with many disadvantages too, where it is only for short distances because such a small vehicle, I doubt that it can travel long distances. So yeah, this one it only can go for like short distances around maybe 2 km around there. And this is only for one person, so it'll be everybody will have their own personal jetpack and it can't be shared. Yeah, that's all. Thank you.
Hello judges, I am Liang Jin and will be representing the team for the introduction of our prototype. I would also like to introduce my fellow groupmates, Chloe, Marcus and Jia Xuan. The operations start with the deployment of garbage boxes. These are boxes that are colored according to the materials intended to contain. For example, red colored garbage boxes are for recyclable plastics. Brown boxes will be for objects that are unrecyclable and should be incinerated. These boxes will be placed in public spaces and provided to homes to function as a place to dispose of objects. Drones will constantly patrol these areas through program route mapping. When garbage boxes are filled, they emit radio signals to nearby patrolling drones. These drones will arrive and grab the box, spray disinfectant, and redeploy a new bag if necessary. Let's see how this is played out in the HDB corridor. Colored garbage boxes are filled with sorted recyclables and are placed by residents outside residential main gates along corridors. These boxes will be picked up by the junk collectors. Garbage boxes are transported to nearby collection points for disposal. The boxes are reusable and made of biodegradable materials. Boxes with recyclables are sorted automatically based on the color of their boxes. Drones will then resume on their route, allowing the cycle to repeat itself. I hope this introduction will aid in your understanding of our prototype and how it functions. Thank you for your kind attention.
We got inspiration from elderly who have difficulty walking. Since the rubbish chute is in the corridor for most HDB flats, this gives them a lot of trouble just to throw their trash away. Not only that, they have to do this daily, which might affect their walking abilities. Therefore, we came up with an idea for the drone to fly to their doorstep to collect their rubbish and fly back to the incinerator in Singapore.
So when I was thinking for the designs of our drone, I randomly came across a picture I found on Google, and I thought it was super suitable for our drone as its aesthetics and model was quite unique. So I illustrated the design on our planning paper. I basically made the exact same drone and made some changes to the bottom of it so that the drone can be attached to the rubbish box and deliver the trash over to the incinerator. After this design has been added, we are able to build the drone and finalize our project.
One of the problems we faced was the preparation of the video. We could not meet up to work on it due to the pandemic. This made it more difficult as we did not have a direct form of communication with each other. We also had to work on the prototype, background, and the video by ourselves, and we could not receive any help from each other when we needed it.
From the project, I managed to develop my soft skills like communicating with my group mates and helping them organize many tasks at hand. It also taught me how to be able to juggle my workload with my academics and CCA commitments while managing the project at the same time. I found this project very meaningful as it was the last project we had before we were moving to different classes in secondary 3. I am truly grateful I had participated in this project and I enjoyed the time I had with my group mates.
The CVSS Aeronautics Club aims to engage students like us who are passionate about aeroplanes. We are provided with guidance and opportunities to deepen our understanding in the science of flight and develop our skills in designing, making, and flying various types of flying machines. Junior members begin by learning the basics of flight principles through sharing sessions and workshops. Such sessions are conducted by our seniors and alumni who have gone on to pursue aero-related courses in the polytechnics. We also participated in hands-on activities such as the making of paper planes and straw gliders. Soon, with adequate basic knowledge in flight principles, we began to make foam and balsa wood gliders, where we acquired deeper knowledge and D&D skills along the way. As members gained more experience, we were guided to design our own gliders by exercising our creativity to come up with unconventional designs that follow flight principles. Along the way, we also improved our skills in crafting sleek wood gliders. One of our main challenges was to participate and excel in competitions such as the Singapore Amazing Flying Machine Competition. Meanwhile, enthusiastic members started their training with the making and flying of fixed-wing radio-controlled planes. Conducted during weekends, the RC flight training enabled members to experience motorized plane making that integrate aerodynamic principles with physics and engineering concepts. Such training sessions were usually conducted on Saturdays with a small number of members due to venue and resource constraints. Sec 2 members then proceed to fly quadcopters such as the DJI Tello. From there, we learned block programming for autonomous drone flying and explore a drone's journey through the use of coding apps. More enthusiastic members embarked on our journey in FPV drone racing using the brushless quadcopters and transmitters purchased by schools. During competition downtime, Sec 2 and 3 members utilized the opportunity to fly the latest Microsoft flight simulators using school laptops and joysticks. Workshops on aviation science were also organized to share practical knowledge in aviation such as the meta code, takeoff and landing protocol, wind correction and fuel calculation. Over the years, the club has nurtured a number of students who went on to pursue related STEM courses in the polytechnics. Our ex-chairperson, Ko Ziwang, was one of them.
Hi, I'm Ko Ziwang from 4E6 and my dream is to be a pilot one day. I also hope to put Singapore on the world map in terms of the aviation industry as well as the drone industry. Since primary 4, with strong influence from my father, I got very interested in flying model aeroplanes. I also discovered on the way that I have a strong sense of 3D spatial awareness and that made me competent in being able to fly model planes of all sorts. Now after PSLE, I was torn between choosing Edgeview Secondary School or CVSS. On one hand, Edgeview offered Singapore Youth Flying Club as a CCA. On the other hand, CVSS had the Applied Learning Program in Aeronautics as well as the Aeronautics Club. After going to the open house with my parents, I chose CVSS as my final choice and, well, I never looked back since. On my own, I had put in more than 1,000 hours of flight time to improve my flying skills. I also used my limited free time to read out a more advanced knowledge in aeronautics. To me, there's still a long way ahead before I reach my goals, and there's no time to waste. I will continue to strive hard and even harder in order to excel and make my family, my school, well, and hopefully my country proud of me one day.
That was refreshing to hear the next generation of future aviation leaders share their school experiences. Some of you have been patiently waiting and are eager to find out more about the resources. Please refer to the link in the chat box or scan the QR code on the screen to access the resources kindly shared by the schools. We have 1 minute for you to access the information and you can download it anytime after for up to 1 month. You may also take a screenshot or picture of this slide for your reference in future. I wonder what the upcoming developments are available in Singapore from the aviation industry. In the final video of this segment, let's hear from Aspire Lab about the next sensational event called Space Expedition 2022 happening at Science Centre in June.
5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Space exploration and technologies are becoming increasingly accessible and at a faster rate. Space offers a lot of potential for discovery, for learning, for innovation as well. One of the events that will be happening across universities in Singapore this year will be Space Hackathons hosted by Aspire Labs. So SIT will be organizing a hackathon. The topic will be on sustainable living in space. I think this is a very important and appropriate topic given the importance of sustainability issues today. Choosing this particular topic of sustainability will push our students to think beyond the present. In the event that one day we have to colonize space and live in space, we want to get sustainability right from the very beginning.
This year at the Science Centre Singapore, we are running a whole series of activities and competitions to get students excited. There's going to be a space sci-fi contest to see who can come up with the best ideas of life in space. We'll also be having a space exploration journey with hands-on workshops where students can get a chance to carry out a mission with a space rover. And in June, we'll be having a Space Science Week where we will be recognizing the efforts of contest participants and showcasing their work to our special guest, NASA astronaut Jeff Williams, who will be here to share his experiences of his time in space with us.
As a professor in innovation and a technopreneur myself, I'm always thinking about tech innovations and their application to our lives. As we move towards the new space, technology will evolve and improve rapidly, constantly opening new commercial possibilities. The Space Expedition 2022 presents an opportunity for entrepreneurs to feature their technologies and network with like-minded astropreneurs and explorers in uncovering exciting innovation and business opportunities so that they can be part of the new space. With space tourism opening to the common man, the possibilities are endless. Space inspires innovation.
Space excites curiosity.
Space creates opportunities.
Join us at Space Expedition
2022.
See you there.
We have come to the end of the first segment of AeroCampus 2022 Virtual STEM Workshop. We hope you have enjoyed this segment looking at all the various school programs shown here. Do give us a thumbs up or a happy emoticon if you have enjoyed it. Thank you for staying on so far and enjoy the rest of AeroCampus 2022. After this, from 11:30 to 12:30, there will be a live aerial flying display on the live Facebook channel. We will share the link with you in a bit. You may choose to log off and hop on to the Facebook Live page and join us back here with the same Zoom link for the next program. Live STEM chat with Dr. James Wang and Dr. Neil Kok Bing, happening at 1:30 p.m. We will still be here to hang around with you and answer some of the questions or comments you may have. Feel free to stay on in this Zoom and type your comments or questions in the chat box. Our team from the Airshow organizers and Science Center staff will try our best to answer your queries as much as we know. Before we end off the first segment of AeroCampus, let us watch a video that showcases the highlights of the Singapore Airshow 2022. Thank you for staying on. Sadly, we have come to the end of the first segment. This is Cameron signing off from the STEM Virtual Workshop.